Welcome back. In our fourth solutions video, we talk about solubility behavior. Now let's define what the solubility of a substance is. It is defined as the amount of solute, so how much of a solute can dissolve in a particular solvent at a specific temperature or pressure. There are several factors that affect the solubility. The first one is the nature of the solute and the solvent, then the temperature, and finally the pressure. And pressure only affects gases. So let's look at the nature or polarity of a solute and solvent. Polar solvents will dissolve polar solutes. Non-polar solvents will dissolve non-polar solutes. So there is a rule of thumb that says that like dissolves like, because polar, polar, non-polar, non-polar. Then most ionic compounds, which are extremely polar because they have charged ions, will dissolve in water but will not dissolve in non-polar solvents. When we are talking about two liquids, when two liquids are able to dissolve into one another, this is called miscible. So they are either both polar or both non-polar. An example would be isopropyl alcohol and water. Since we know that water is polar, isopropyl alcohol is also polar, and they will mix. Two liquids that are not able to dissolve into one another are called immiscible, which means that one has to be polar and one non-polar. So again, in our example of oil and water, since we know that water is polar, oil has to be non-polar. And we can see that in the picture here. Water and methylene are immiscible. They form two separate layers. Acetone and water are miscible. We form one uniform layer. Let's practice this. Pause the video, read the information, and label the 5 substances as polar or non-polar. Here are the answers. If you got it right, great. If not, remember like dissolves like, and ask your teacher for help in class. The second factor that affects the solubility of a substance, that is how much will dissolve, is temperature. For solid solutes, generally, as temperature increases, the solubility of a solid solute also increases. So you can think of when you dissolve sugar in hot tea or iced tea, more sugar will dissolve in the hot tea than the iced tea. For gaseous solutes, it is the opposite. As the temperature increases, the solubility of a gas decreases. For example, a hot or warm can of Coke will go flat faster than a refrigerated Coke because the carbon dioxide will escape the solution. Less will be dissolved. We can see that in the example here. At a low temperature, we have more gas particles dissolved in the liquid. And at a high temperature, the gas particles escape and we have a lot less gas particles dissolved in the liquid. Finally, we have pressure, and remember we said pressure affects the solubility of gases only. So an increase in pressure will increase the solubility of a gas into a liquid. As you can see here, there are gas particles above the liquid. At low pressure, if I increase the pressure, it's almost like I'm pushing those gas particles more into the liquid, so more gas particles will dissolve. Finally, we are going to look at the rate of solubility. If a substance can dissolve, the rate of solubility of a solute is how fast that it will dissolve. So there are 3 factors that affect the rate of solubility. One is temperature. So if we increase the temperature, there is more kinetic energy, more collisions, so the solute will dissolve faster. Agitation or stirring or shaking, we have more contact with the surface of the solute particles. So again, if you have agitation, you will have the solute dissolve faster. The third factor is surface area. For the same amount of solute, small particles will have a greater surface area for the solvent to reach, and this will lead to faster dissolving. So if we look at this picture, the large sugar cube has 6 sides for the solvent to reach the sugar cube. I'm showing you 4. But if I take this very same sugar cube and I crush it into thousands of little pieces over here, now the solvent can reach in between all these very little pieces, so there is a much bigger surface area with the little pieces for the solvent to reach, and that will dissolve a lot faster. Last quick note, it is very common that students mix up solubility versus rate of solubility. The solubility is how much of a solute will dissolve, and the rate of solubility means how fast that solute will dissolve. So please make sure that you really can distinguish between those two. This is the end of video 4. I hope you have taken high quality notes. Come to class prepared with your questions.